Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to discuss about ionic equilibrium. So, I will discuss on electrolytes, strong electrolytes or weak electrolytes, non-electrolytes, theories of acid and bases like Arrhenius concept of acid and bases, the Bronsted-Loddick acids and bases, Lewis acids and bases. So, what is electrolytes? You know the substances like acid, base and salt, which can conduct electricity in their aqueous solution due to ionizations are known as electrolytes. You know, my friend, the presence of ions in solution is responsible for the conductions, and when the current passes through the wires, it shows the movement of free electrons through the wire. This process of dissociation and the flow of ions in aqueous solution of electrolyte is known as electrolysis. For example, electrolysis of sodium chloride in its aqueous solutions gives sodium and chloride ion in solution. So, there are many electrolytes present in the human body, such as sodium, magnesium, calcium, potassium, chloride ion, and bicarbonate ion. These electrolytes involve in various functions of our cells and our organs. So, the main electrolytes in our body fluid is sodium plus ions or sodium ion, chloride ion, magnesium ion, calcium ion, and potassium ion. Each ion has its own rules, and body movement is a result of the functions of these ions. Now, examples of electrolytes: hydrochloric acid, nitric acid, sulfuric acid, hydrobromic acid, hydroiodic acid, perchloric acid, acetic acid, carbonic acid, ammonia, lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. Now, what is strong electrolytes? Some electrolytes such as potassium chloride or sodium hydroxide, sodium nitrate are completely ionized in their constituents ion in solution, and these electrolytes are known as strong electrolytes. In other words, strong electrolytes are 100% dissociated in their aqueous solutions. For example, KCl gives K plus Cl minus, ammonium nitrate gives ammonium ion and nitrate ion in aqueous solution, nitric acids H plus and nitrate ions, and sodium hydroxide sodium plus and OH minus. So, strong electrolytes like salt are composed of oppositive charge ions. In solid state, these ions are held by strong electrostatic forces of attraction. When these electrolytes are dissolved in water, an attraction force between the ions are highly weakened due to high dielectric constant of water, that is AT. So you can see in this pictorial diagram. So list of strong electrolytes like chloric acid, sulfurous acid, hydroiodic acid, hydrobromic acid, hydrochloric acid, sulfuric acid, and nitric acid. So weak electrolytes. You know, electrolytes which are weakly ionized in their aqueous solution are called as weak electrolyte. In the aqueous solution of weak electrolytes, the constituent ions are in equilibrium with undissociated molecules of the electrolyte. My friend, due to partial dissociation of electrolytes, The number of ions in a given volume of a solution is almost remains same for a large change in the concentration. So you can see, you know about the acetic acid, hydrolysis, it reacts with water and forming H3O plus and acetate ion. So such type of equilibrium exists between ions and ionized molecule is called as ionic equilibrium. The fraction of molecule dissociates can be represented by using a degree of dissociation. Generally, weak acid and bases are a good example of weak electrolytes. You can see hydrocyanic acid gives hydrogen ion and cyanide ion. Ammonium hydroxide are in equilibrium with the ammonium ion and hydroxide ion, and mercury chloride in equilibrium with the mercuric ions and chloride ion. So list of weak electrolytes like acetic acid, hydrocyanic acid, ammonium hydroxide, ammonia, hydrofluoric acid, carbonic acid, mercuric acid, chromic acid, and boric acid, nitric acid, like this. So what is non-electrolytes? Non-electrolytes are substances which cannot conduct electricity in their aqueous solution due to the absence of ion. You know, they are generally polar or non-polar covalent compound which can dissolve in water as molecules instead of ion. You also know a covalent compound contains covalent bond between the bonded atom, therefore cannot be ionized in their solution and exist in the form of molecule only. For example, sugar alcohols are soluble in water but remain in molecular form only. Now, examples of non-electrolytes. Non-electrolytes, sucrose, glucose, ethanol, same chemical formula you can see here. This is the list. So, Arrhenius concept of acid bases. You know, in 1884, Swedish chemist 70 August Arrhenius proposed that acid and bases can be defined in terms of the chemical species they form when they dissolve in water. So, Arrhenius acid, according to Arrhenius theory, acid is a substance which has a hydrogen atom and can be given in the form of hydrogen ion in aqueous solution. Such substances are called as Arrhenius acid. For example, when acetic acid dissolves in water, it will form acetate ion and hydronium ion. You can see here. So, in the same way, HCl acts as a Arrhenius acid in water and it converts to Cl- ion by transferring hydrogen ion to water. So, when Arrhenius acid are in pure state and they are covalent compound, that is, they do not contain this plus ion. The ions are formed through an interaction between water and the acid. Then they are mixed. You know, ionization is the process in which individual positive and negative ions are produced from a molecular compound that is dissolved in solution. So you can see ionization, no ion initially presents. So, strength of Arrhenius acid. On the basis of ionization of acid, they can be classified into two types. A strong acid, those acids which are completely ionized and give maximum number of protons in a solution are known as a strong acid. The value of acid dissociation constant or a strong acid K is very high. Hence, the strength of acid is directly proportional to the acid dissociation constant K. For example, HCl, nitric acid, sulfuric acid. It is. On the other hand, weak acid, those acids which are partially ionized in solution, like acetic acid, hydrofluoric acid, are known as weak acid. The acid dissociation constant is less for weak acid compared to the strong acid. For example, acetic acid, carbonic acid, and phosphoric acid. So these are the list. Now, Arrhenius base. An Arrhenius base is a hydroxide containing compound that produces hydroxide ion in water. The basic species in Arrhenius theory is thus the hydroxide ion. For these reasons, Arrhenius bases are also called hydroxide bases. You know, sodium hydroxide on dissociation it gave Na plus OH minus. Now, strength of acid bases of Arrhenius. On the basis of ionization base, they can be classified into two types: strong bases, those bases which, when dissolved in water, dissociate completely to give OH minus ion, are known as a strong base. The value of base dissociation constant or the strong basis is very high. Hence, the strength of base is directly proportional to the base dissociation constant. Weak base, those bases which are partially ionized in solution, are known as weak bases. The base dissociation constant is less for weak bases compared to the strong base. Now these are the list. So, limitations of Arrhenius concept. This concept could not explain acidic and basic character of the certain substances such as ammonia, ammonium carbonate, calcium oxide, and carbon dioxide, sulfur dioxide, and sulfur trioxide, which do not contain H plus OH minus I. It could not explain the reactions between an acid and base in absence of water. So, Bronsted-Lowry acid and bases. Bronsted-Lowry independently developed the theory of proton donor and proton acceptor in acid-base reaction. Coincidentally, in the same reasons during the same year, the main effect of the Bronsted-Lowry definition is to identify the proton transfer occurring in the acid-base reaction. This is the best illustration in the following equation. HAZ, it gives A minus AZ. So, donate hydrogen ions, accept hydrogen ions. You can see. Now, what is the acid? An acid is defined as a substance which has a tendency to give protons. An acid is a proton donor. A base is defined as the substance which has a tendency to accept protons. A base is proton acceptor. You can see here. So, important result, HCl is an acid because it donates a proton to water and to ammonia. Ammonia is base because it accepts a proton from water in and HCl, and water act both as acid as well as base, and hence is called amphoteric. Now, to determine whether the substance is an acid or base, count the hydrogen on each substance before and after reaction. If the number of hydrogen has decreased, that substance is acid, donor hydrogen. If the number of hydrogens has increased, the substance is base, except hydrogen. This definition is normally applied to the reagent or reactant on the left. If the reaction is viewed in the reverse, a new acid and base can be identified. The substances on the right side of the equation are called conjugate acid and conjugate base compared to those on the left. Also note that the original acid turns in the conjugate base after the reaction. You can see here conjugate pair. So, advantages of Bronsted-Lowry concept. It is not limited to the molecules but include even the ionic species to act as acid or base. It does not require aqueous medium to explain acidic or basic nature. It can explain the basic nature of ions or molecules having no OH minus. Examples: ammonia, sodium carbonate. Limitations of Bronsted-Lowry concept. It could not explain the acidic and basic nature of the compound having no tendency to lose or gain H plus ion, like CO2, ammonia, sulfur dioxide, sulfur trioxide. It could not explain the basic nature of the compound having OH minus ion, like sodium hydroxide, calcium hydroxide, and potassium hydroxide. So, Lewis acid and bases develop. So, from this topic I will discuss in my next video. If you like this type of video, then subscribe my channel, and thanks for watching.